All right, folks, here we are. Now that we know the fundamental theorem of calculus, we are going to learn how to solve definite integrals, or evaluate, really is the better word. We're going to evaluate definite integrals. And what I'm going to do is I'm just going to give you a brief procedure on how to do a definite integral. It's really easy if you know the fundamental theorem of calculus. This is a definite integral. How do you know it's a definite integral? Because it looks like an indefinite integral. It's got the integration symbol, it's got the dx, it's got an expression, but it has numbers. It has a lower limit of integration and it has an upper limit of integration. And here's how you do a definite integral. These are a piece of cake. Well, the hardest part about them is if you have a really difficult integrand, then they can be a little challenging. But generally speaking, these are really easy. Your very first step. Step one, now this is the way I do it. Step one, identify the antiderivative of the integrand. Now, you may say, Mr. Ryan, I don't know what an integrand is. Well, I did mention it in a previous video. The integrand is the expression on the inside of the integral. So in this case, 12x to the third minus 2x, that is the integrand. And that's what we take the integral of. That's what we find the antiderivative of when we're doing an antiderivative. So identify the antiderivative of the integrand and put it inside of brackets. Put it inside of brackets. So, over here, the antiderivative here is going to be, we're going to power up. This is x to the fourth. Then we're going to divide by 4. 12 divided by 4 is 3. So the antiderivative of this piece is 3x to the fourth power minus the antiderivative of 2x. Power up, that's going to be x squared. Divide by 2. 2 divided by 2 is 1. So it's just x squared. This is the antiderivative of this. And so we're going to put it inside of brackets. Now, I want to clarify something here. You don't have to do it my way. And your teacher or professor may do this a little bit differently. I have seen this procedure done probably in about 4 or 5 different ways written down. But it's always the same procedure, it's just written down differently. So the way that I write it with a certain clarity because it's what I prefer. But if you see someone else doing it a little differently, then you can do it their way. Okay, but this is how I do it. Step 2, all right. Put the limits of integration, put the limits of integration which are 2 and 4 in this case, put the limits of integration outside the right bracket. Outside the right side, the right bracket. So in this case, this is the left bracket and this is the right bracket. Outside the right bracket is over here. This is outside the right bracket. Okay? Outside the right bracket, at the top and bottom, at the top and bottom, respectively. So, this is the top, this is the bottom. Respectively means the upper limit, which is at the top, is going to be put at the top outside the bracket. So I'm going to put the 4 here. The 2, which is the lower limit of integration, is at the bottom, so I'm going to put it at the bottom over here. That's step 2. So after you get the integrand or the antiderivative and put it in brackets, just write the limits of integration, top and bottom, right here, ready to go. That's step 2. Step 3, plug the upper limit into the antiderivative. Plug the upper limit into the antiderivative variable So there's a variable that we integrated with respect to. Plug the upper limit into the antiderivative variable and evaluate. And evaluate. Write the answer in parentheses. Write the answer in parentheses. Here's what I mean. See the upper limit? We're going to plug it in for x here, and we're going to plug it in for x here, and we're going to get a number. So 4 to the 4th power, we might need a calculator for this. So 2 something, 4 to the 4th power, 256 times 3. $768 minus 4 squared. So that's minus 16. That's 752. And we're going to write that in parentheses. 752 in parentheses. Okay, we just did step 3. Step 4. Put a subtraction symbol. Put a subtraction symbol. All right, so I'm going to put a subtraction symbol. All right. Step 5, 2 more steps here. Step 5, repeat step 3. Repeat step 3 with the lower limit. With the lower limit. What I mean is, go back to step 3. Instead of plugging the upper limit into the antiderivative, now we're going to plug the lower limit into the antiderivative variable and evaluate. So, plug a 2 in. 2 to the 4th power, that's 16. 16 times 3 is 48. 2 to the 2nd power, that's 4. So 48 minus 4 is 44. And we're going to put it in parentheses right here. There we go. And so now, we have a difference now. And step 6 is evaluate the difference. Evaluate the difference. And so, 752 minus 44, that's 708. And that is our answer. That is our definite integral. So, the definite integral from 2 to 4 of 12x to the 3rd minus 2x dx, the answer to this is 708. That's it. That is the definite integral. Like I said, definite integrals, the answers to them are values. Let's do a couple more examples. All right, folks, I know now that you have seen the procedure for doing a definite integral, someone out there, while you were watching the video, you were like, wait a minute, Mr. Ryan, what happened to the plus c from the indefinite integral? What happened to that thing? I'm glad you asked that. I'm about to explain that to you right now, okay? So here's what we're going to do. We're going to do the definite integral based on the procedure that we just learned. And while we do it, we are going to include the plus c. And here's what you're going to find, is that in every single case in a definite integral, the c cancels out. So we just don't worry about the plus c in a definite integral. So let's do this. Step 1 says identify the antiderivative of the integrand. Well, the antiderivative of 5x to the 4th, well, the power is going to go up by 1, so it's going to be x to the 5th. Then we're going to divide by the new power, 5, and 5 divided by 5 is 1. So the antiderivative here is going to be x to the 5th power. We're going to put it in brackets, but we're going to put on the plus c. So actually we're going to put in x to the 5th plus c, because that is technically the indefinite integral. That's the antiderivative of 5x to the 4th, right? Now, just like what we just learned, we're going to put the 2 up top here, and we're going to put the 1 down here. And now step 3, we're going to plug in the upper limit of integration. I'm going to plug the 2 in here. 2 to the 5th power is 32. But I'm not going to write 32. I'm going to write 32 plus c, right? Plus c in parentheses. Step 4, I'm going to put a subtraction symbol. Now I'm going to plug the 1 in. Step 5, I'm repeating step 3, but I'm using the lower limit. Plug a 1 in. 1 to the 5th power, that's 1. But it's not just 1, it's 1 plus c. So I'm going to put 1 plus c in here. And then step 6 says evaluate the difference. Now I want you to look at this. when we evaluate this, what's going to happen to the c? See, we have 32 minus 1, that's 31. But look at this c. We have c minus c. Well, what's c minus c? It's 0. It cancels out entirely. And that is what happens with constants when you're doing a definite integral. See, when definite integrals are done, what they're evaluating is, and we'll get to this later, but what they're evaluating is an accumulation of change. This is a rate of change, and we're going to accumulate that change between 1 and 2. When we accumulate change, at 1, the constant was there. At 2, the same constant was there, but we're not accumulating the constant, we're accumulating the change. Therefore, the constant subtracts away the constant, and it's like it was never there. Okay? So, this c is always going to cancel out. And because the c is always going to cancel out, when we do a definite integral, we just don't include the plus c inside the bracket. We just put x to the 5th between 1 and 2, plug in the 2, and we get 32, minus, plug in the 1, and we get 1. 32 minus 1 is 31, and that is our definite integral. Okay? So, remember this as we do the next few problems. Remember that we're not going to put the plus c in a definite integral. However, when you're doing an indefinite integral, you must remember to put the plus c. All right, here's one. You're probably going to need a calculator for this. Now, you don't actually need a calculator because you can record your answer in terms of e if you want to. In fact, a lot of professors or teachers do want you to do that instead, but I'm going to do it with a calculator. So let's see here. Step 1 is identify the antiderivative of the integrand and put it inside of brackets. So I'll open my bracket here. The antiderivative of 3e to the x is 3e to the x. Plus, the antiderivative of 5 is 5x. Close my bracket. Put my limits of integration, 0 to 3. Next step, plug the 3 in. So I've got 3e to the 3rd power plus 5 times 3. Well, that's 15. So in here, I'm going to put in 3e to the power of 3. 3e to the 3rd power plus 5 times 3 is 15. And that gives me 75. I'll put it in parentheses, 75.25661. 25661. Minus, that's step 4, put a minus symbol. Now, I'm going to plug 0 in. Well, e to the 0 power, that's 1. 3 times 1 is 3. 5 times 0 is 0. So 3 plus 0 is just 3. So minus 3 in parentheses. Well, let me clean that up a little bit. I mean, you don't always have to use parentheses. I use parentheses when I'm teaching because I don't want students to forget to distribute this minus when there are multiple parts of this number. Okay? So now, 75.25661 minus 3 is 72.25661. And there is the definite integral of that. Okay? Let's do a couple more. All right, here we got another one. We've got the definite integral of 7 over x from 5 to 18. Well, the antiderivative of 7 over x is 7 times the natural log of the absolute value of x. And we're going from 5 up to 18, right? Now, we're going to plug in the 18 first. So we're going to do 7 natural log of 18. So 7 times the natural log of 18. And that's going to give us 20.232602. 232602. Close parenthesis, minus, open parenthesis. Now we're going to plug the 5 in. 7 natural log of 5. 7 natural log of 5 gives us 11.266065. 266065. And now I'm just going to subtract these numbers. 20.232602 minus 11.266065. And I get, my final answer is 8.9665. There we go. That is the final answer. Okay? Let's try maybe just one or two more. All right, this one looks sort of crazy, but it's a definite integral. We can do it. We got a calculator here, and because it's got a trig function, we're going to want to make sure that we are in radian mode. So I'm going to hit the DRG button, go over to radians, press enter. Your calculator may have a mode button in which you want to move it over to radians. Okay? So first, identify the antiderivative of the integrand. The antiderivative here is going to be, antiderivative cosine is sine of x. So sine of x plus, and if you recall, this is the derivative of tan inverse of x. So the antiderivative of this is going to be tan inverse of x. I'm going to close it off with a bracket. And then what we're going to do is plug in the upper limit, or we got to put our limits of integration on here. We got to put a 1 and an 8. 1 is the lower limit, 8 is the upper limit. Now we're going to plug 8 in. So we're going to do sine of 8 plus tan inverse of 8. Now, your calculator hopefully has a way, if you hit a second button and then tangent, you might get tan inverse. So I'm going to do sine of 8 plus second tan gives me tan inverse of 8. And I press enter, and I get 2.4357. 2.435799. Okay, put that in parentheses. Minus, now I'm going to plug in 1. Sine of 1 plus tangent inverse of 1, and I get 1.626869. Okay, and now I just do this number minus this number. So 2.435799 minus 1.626869, and I get 0.8089. Is my final answer. That is the definite integral of that. All right, I just want to do one more example, and you should be pretty solid on definite integrals. All right, I don't think I'd be doing my job if I didn't do at least one that has a radical in it, right? Okay, so here we have the definite integral of the square root of x from 1 to 16. Step 1, identify the antiderivative of the integrand and put it inside of brackets. What I'm going to do is I'm going to rewrite this as the antiderivative of x to the 1/2 power dx. I'm just doing some side work here so I know what to put in the brackets here. And the antiderivative here, so x to the 1/2, because the square root of x is x to the 1/2, I'm going to add 1 to the power here. So 1/2 plus 1 is x to the 3/2 power. So we've got x to the 3/2 power. And we have to multiply by the reciprocal of the power. The reciprocal of 3/2 is 2/3. So 2/3. And so in the brackets, we're going to put 2/3 x to the 3/2 power. All right. Now, actually, what I want to do is, you know what, let me not write that. Hang on. Let me show you why. It's easier to evaluate when there's a radical symbol, but it's easier to integrate when it's a fractional power. I'm going to turn this into 2/3, and then look, this is the square root of x to the 3rd power. So I'm going to put square root of x to the 3rd power. So I'm going to write this up here, 2/3 times the square root of x to the 3rd power from 1 to 16. And now, we're going to evaluate. We're going to plug 16 in, and now here's what I want to tell you. The square root of 16 is 4, and then 4 to the 3rd power is 64, and then 64 times 2/3 is 128/3. Okay? And just confirm here, and which is not a whole number. Okay, so we're going to leave that as a fraction, or sorry, I don't need a bracket there. 128/3. I'm going to do a parenthesis, 128/3 minus. Now we're going to plug the 1 in. Well, 1 to the 3rd power is 1, and the square root of 1 is 1, and 1 times 2/3 is just 2/3. Now, if you leave these in fractions, usually what you're going to find is you have to do subtraction. If you leave it in fraction form, usually you'll find that they already have a common denominator. And so now we're going to do 128/3 minus 2/3. Common denominator is 3, and 128 minus 2 is 126. And so our final answer is 126 over 3. That is our definite integral. Now, I promise you, there is no way in the world that you're going to be good at this unless you practice it a lot, which is why I give you a whole bunch of problems to practice. What is this? There's 30 of them here, and you can find plenty more on the internet, and you can find more in your textbook. There are plenty of definite integral problems out there that you can just keep churning out, okay? So that you can be very, very good at this. The better you are at definite integrals, the better that you will be in general at calculus, because a lot of things, a lot of real-life problems in calculus are definite integral problems. But that's all I have for you today, and I hope you get good at this. And when you get back, we will start applying definite integrals.